Okay, welcome back to the KWIK-WAY valve grinder repair or rebuild. It's not really a rebuild, I guess. It's more of just a clean up and use. Remember, the reason I wanted to clean this thing up and make it usable is for the valves on the Big Cat diesel engine. So, the generator set, rather. So, at this point, the base, the main body has been cleaned up pretty well. As well as I think it needs to be. All of the dovetails for the ways on the, I guess the grinding spindle have been cleaned. There's very minimal wear on them. It was just all packed full of grit and dirt, just accumulation over the years. The grinding spindle slide and its mating V dovetails have been cleaned up very well. Again, minimal wear on really this whole machine. I did took a look at the bearings for the spindle. They're a ball bearing. I could probably replace them. They're a Fafner bearing, so they got a part number on them. Should be easy enough to replace. But they seem to be in really nice shape. They spin freely with no noise. There's no appreciable slop or play that I can detect, so we're going to run them, see how they do. But at this point, I think I'm going to start reassembling the clean parts that I have just to make some space on the bench and prevent things from getting lost. Again, that was the grinding spindle, the driven worm gear with the belt pulley that'll drive the working spindle. So that cleaned up really well. And then the driving gear for the rack, pinion gear I guess you call it, that is inserted here and actually drives the grinding spindle back and forth. So I'm going to move you around, start reassembling this, and keep you updated. Alright, let's start a little bit of reassembly here. Just going to put a little bit of oil down on the in these grooves here. And I'll put some oil on the spindle as well. Bring that over here. Alright. Now here's the gib. Put a little bit of oil on that. Just slide right in. Now we got 5 gib screws. Getting a good look at that. Or am I standing in the way? I know, not the most fascinating part of reassembling this machine. Show you one of these screws up close. got a nice tip on them there where they sit into the slot of the gib. This one here, I'm not sure, but it looks like somebody's taken that to a grinder at some point for an unknown reason. Here's an original, or I think this is an original, but this is a modified gib screw here. Somebody ground that down. Don't know why, but I don't think it's gonna hamper the operation of it at all. So it's going back in. So I'm just going to seat these very lightly and spin the jam nuts on. Throw a little bit of oil down these wells here. All right. These jam nuts are a peculiar size. They're 15mm hex, which is strange for this a unit of this age, given that I haven't run into anything else that's been a metric size while disassembling it or cleaning it. That one doesn't seem to be threading on there quite right. I might have to run a tap through that nut. Let's take that one out. Yeah. Not quite right about that one. Take that screw out. Yep. Alright. Let me stop you while I run a tap through that. See what's going on. Okay, yeah, running a tap through there took care of it. Might have been just a little burr or a piece of dirt in there that was holding the program up. So all the nuts are loose. The gib screws are just lightly seated. So we can install the rack driving gear, pinion gear here. Now I'll show you this before I install it. Can you tell that, there you go, that the bushing or the housing is a concentric circle. The central shaft is drilled at an offset, or is off center. I don't know if you can tell, you see the gap there and then up here. It's very slight. That allows you to set the mesh of the rack and the pinion here. So go ahead and put a little bit of oil on that. Oil the shaft up a little bit. I had the shaft out of the sleeve and I oiled it up then, but put a little bit of oil in the bore here. Now this is held in with just a set screw. So let's flip the thing on its side here. And I'll change your angle. Give me 1 second. Alright, well I brought you down here, but then I realized that you really can't see anything. So this is the bore in the casting where the rack, or sorry, the pinion gear is going to sit here. I just pulled it back out, and there's a single set screw hole there. And I mentioned that the shaft is not in the dead center of the sleeve here, and that's so you can rotate the sleeve and set the mesh of the gear. You can see barely that there's evidence or a mark left from the set screw originally, so I'm just going to try to line that mark back up and set the clearance as it was. Let's see. Looks like right about there. I can see the mark in the sleeve through the set screw hole, so I'm just going to snug that down and we'll flip it up and see how it meshes. Alright, that's snug. Move you back. The handle on. Yeah, I don't feel any binding in the gear in the rack of the pinion, so I'm going to leave it as it is. There's some backlash. That's mostly just the handle on the key here. Backlash here as well. Looking at the sleeve, I'd say that the gear is actually, the pinion is actually pulled away from the rack as far as it can be. Let me see if rotating it makes any difference to that backlash. Might be a bit difficult to do. Loosen that set screw. Oh, there's a limit to how far I can turn the sleeve, so that must mean that at this point the pinion is bottoming out against the teeth, the crests of the teeth on the pinion are bottoming out against the valleys on the rack. So I'm gonna turn it around till they bottom and then back it out a little bit, and we'll try it again. See how that feels. Snug it up. Yep, I can feel it binding now a little bit. So, I guess where it was is where it's going to stay. Let me return it to that position. It's about there, I believe. Just knocked something on the floor there. Gotta be careful. Yeah, that's better. It's right where it was, moves freely now. So I'm going to tighten that set screw and then work on the gibs. Tighten them up. Alright, so this has been a pretty productive day on the KWIK-WAY valve grinder here. It's been a couple hours since the last clip, and gotten you saw the carriage get put back on, the spindle carriage there. So I've also reassembled the clutch, put the drive the driven worm gear on that drives the little leather belt that drives the work spindle here. Put the guard back on for the arbor. Cleaned out the spindle bearing oil troughs. Made new gaskets. Cleaned the covers up. Reinstalled them. So it's looking pretty good right now. I can't turn it by hand to move it for you there. But I want to put the motor back on now, and that'll allow me to actually spin the thing up and see how it does. So I mentioned before that this is a little General Electric single phase. I believe it's a 1/4 horsepower motor. Take you off the stand here. So I'm not all that familiar with these little General Electric motors. This is a brushed type motor. I didn't realize that at first. I like the form of the I guess terminal block / brush block. Just sits right on there, and you just take these two looks like, you know, brush assemblies out, and you put the wire right underneath there. Like a big ring terminal almost. So that'll be easy to replace, or rather be easy to connect a new piece of lead wire to. Brushes move freely in their holders, got plenty of length, they don't look burnt. Got the slip rings there on the rotor shaft. You can see the shaft spins very easily and freely. So I think this is going to be in pretty good shape. I'm on the fence about taking it apart, but I took the rest of the machine apart, so it would be foolish to leave this alone. You know, just in case there's something not quite right with it. We'll find out before it becomes a problem. So let me tear that apart, and we'll be back in a sec. Alright, well, I have the motor disassembled here, and I want to talk a little bit about it real quick, because it's a pretty neat little electric motor. It's kind of the inverse of you know, your modern day single phase squirrel cage induction motor, where all the windings, the electrical windings, are on the stator housing of the motor around the outside here, and on the rotor is just a stack of laminations with what is usually just like aluminum bars and a fan cast in the rotor assembly. So this is, like I said, the inverse of that, where the rotor is wound with your windings, and the stator actually just has the laminations here, the stack of iron laminations, and the aluminum, I believe it's aluminum, really these act as the windings in the stator, these aluminum bars that run through here and are tied together on each end. So it's pretty interesting. This little motor also has a centrifugal switch on its rotor, so it has two windings on the rotor, a start and a run winding. You can see the two. There's a winding there, and then one on the outside. It's a really neat little assembly. I took the connections apart just to try to, you know, identify how the centrifugal switch worked. Let me see if I can get this in the shot here. But that little loop right there is the switching point. That's the where the circuit for the start winding breaks. This whole, let me get a little something I can point with. This assembly here is the flyweight, everything down in here, and it pivots on this pin around the back, and there's a piece of spring steel here to keep the switch closed. So this is the switch contact here. Let me see if I can actuate it. So what that does is, when the motor reaches a certain speed, the centrifugal force forces that open, and it breaks the circuit for the start winding, which is these two leads right here, and it looks like the heavier gauge wire is the start winding and the finer gauge is the run winding, if I'm not mistaken. I might have to double check myself there. Let me check. Let's see. Now, I'm going to check resistance of these two windings. That might not necessarily indicate to me which is which, but we got a heavier gauge and a finer gauge wire. You know, assuming that they're a similar number of turns, the heavier gauge should have a lower resistance value. I'm not in the shot, am I? Let's see. So you got 4.5 ohms there. And 1.5 there. And then of course nothing in between the windings. Well, in the mega ohm range. So right, so that would be this. The higher resistance is the start winding, the lower resistance is the run winding. Thinking about that, they might have had that, they wanted that to have a greater resistance so the thing wouldn't draw so much current on startup while the start winding was engaged. Because while the thing is spinning slow, the reactance in this stator here is low. So the thing's going to draw a lot of current. That's why, you know, electric motors draw so much current on startup before they get up to rated speed, is because the reactance in a modern case in the rotor is low, and the counter EMF that's resisting, that would resist or impede the flow of current in the stator, hasn't built up yet. I don't know if I'm making any sense here. Quite a fascinating subject, electric motors and generators. But anyway, time to put this back together, lube up the bearings, and get it on the machine. Alright, well, it's about time to put an end to this video. I did not get where I wanted to this weekend as far as working on the valve grinder here. Ran into one major problem, which it's kind of silly that I didn't think of this ahead of time, and that is the problem of the grinding wheel itself. It seems that the wheel on the machine here is so worn down, enough actually, that it will not make contact with the valve face. So it'll work on smaller valves, if I'm not mistaken, or even the intake valves of the big cat generator. But let me show you. You remember looking at the exhaust valve here. The exhaust valve has this extra little skirt here, which I'm not 100% sure what the function of this is, only that it may serve to kind of direct the exhaust gases up around the valve and away, going out in this direction away from the stem and the guide. So it probably serves to prevent soot and just sludge build up on the exhaust valve guide. So anyway, that being the case, I can't actually choke the valve up on the chuck enough to get it closer to the grinding wheel. I could do it with the intake valves. The intake valves don't have this extra skirt, so I can pretty much bring the stem into the chuck all the way up to where the face of the valve starts, or the head of the valve. So let me show you what I'm talking about here. Okay, so on the machine here, I've got an intake valve in the chuck. Now, the problem I'm having is that as I move the carriage for the grinder spindle in, you can see that it just doesn't quite make it there. And I have the tool, or sorry, the work spindle backed all the way out as far as I can go to where the pulley here is contacting the guard. So I've run out of backward travel. Now, like I said, I could choke up on the valve stem a little bit more, but you know, that's only gonna help me for the intake. It's not gonna do anything for the exhaust valves for me with that shoulder. And of course, the exhaust valves are the problem, or the main problem rather. So that's going to be about all for this video. I will show you the machine running, just so you can see how it performs. I remember last week I couldn't remember what this belt material was called. It's polyurethane. This new flat belt material. This is where I joined it together. It's a bit ugly, and I don't think it's, you know, the perfect connection, but it does work. It hasn't blown apart on me yet, and it's still very flexible. So, and that's what they call welding. It's essentially just melting these the two ends together. So, motor's back together. I think you saw that in the last clip. So let's go ahead and power it up. I put you back on the tripod here. I don't have an on and off switch for this thing set up yet. I'll go into that in a second. So we just gotta we'll plug it in. You see that all right? Right. So we're all the way back. The spindle is disengaged from the motor, so we can start the motor up. You can hear the joint in the belt kind of makes a little bit of noise when it goes around the lower pulley there. That's what I think the noise is coming from, because the motor runs silent. So spindle's not turning now. Clutch is disengaged. So as soon as I move the grinding spindle forward, now the grinding spindle is spinning, and so is the work spindle. I can move the valve, the work spindle in and out. And then the operation would go something like, bring the grinding wheel over to the edge of the valve, back the valve up till it just begins to make contact, and then work the grinding wheel back and forth across the face of the valve a little bit at a time, so you get the seat cleaned up. I can move the spindle forward, stop it, change out a valve, come back in, grind the valve. Don't worry, you'll see it actually grinding valves at some point. Said this wheel, I believe, is just worn down enough that I just cannot operate the machine with the exhaust valves. I think this is supposed to be a 4-inch wheel, and it's worn down to about 3.5 right now. Pretty sure I can get these wheels still. Alright, the last thing I want to talk about, I'm going to add a light to this setup. So this, when I'm done, this grinder is going to be permanently mounted on its own little bench with its plugged into the wall, a on and off switch, a toggle switch, and I'm also going to add this this gooseneck light that I've had for a while. I don't know the age or the the provenance of this light. It was just picked up at an engine show. There's no markings on it at all, but it seems quite old and very well made. I've been cleaning it up for a little bit here. So I think originally it was nickel plated. There's a little bit of plating still on the bottom of the shade here and on the inside. But I think I'm just going to leave it kind of like natural brushed metal and mount it something like this. So maybe back here, so it lights the work area up. So that'll be done by the time the next video goes up. Also, we'll have a grinding wheel by that time. So guarantee you, next time you see this, it'll be grinding valves. So thanks for watching. Thanks for keeping up with it. And I want to address a couple of suggestions that were made in the last video. One, you see I got a dial indicator on there. I am definitely going to check the accuracy of the work spindle, the spindle bearings, the ball bearing chuck, which a number of people told me was a kind of a weak point on these KWIK-WAY machines. Not that it was a bad design or anything, but just with age, it seems that they get a little inaccurate. So we will check on that. I don't have a new valve here to check it with. I did check it with, let's see, I think I might have checked it with this exhaust valve here, and I saw about 1,000th worth of run out on the stem and about 1,000th on the face. Now these valves are worn. I don't remember what valve it was actually, but I think it might have been the intake now that I think of it, this intake that's in the chuck now. And there's about 1/2,000th worth of wear on the stem. I don't know what the reject size is from CAT for that, but I imagine it's still in spec. It's not. It is concentric, the stem though. It's worn evenly all the way around. So we got to find out where that 1,000th worth of run out is coming in at. So once I get a new valve, I think 805 Road King's got a valve new in the box from just some automotive application that I can chuck in here and get some measurements done on it. So that'll happen next week, or hopefully next week. So stay tuned, and thanks for keeping up with us.